All right. So we're still dealing with the integration integral or the antiderivative, and here we have a picture that we used last time to establish that sum is related to the antiderivative, and so is the area under the curve. This is time axis, and if we are interested in the area of this curve up to a point t, where this is the function v equals g small t, but this
Sir, we
specific
cannot
height
see your board.
g.
We can see.
Sir,
We can. We can.
yeah.
जी क्या मसला है?
Sir, कुछ नहीं. Please continue.
जी. So, and this here the value of the function would be g capital T, right? Now we did establish that this is the sum of, if we divide it to infinitesimal sums and we add it, this gives us the antiderivative, and that turned out to be today is the last lesson of calculus, so we would move on to studying mechanics from the next lesson. And then we also said symbolically that we can, in a short form, write it like this. Okay, so there is a small thing. So I think when we were doing, so yes, so it's 0 to t v of t and delta t, and this is, we said, is equal to half gt squared. And I'm not sure if we made this argument explicitly. If you look at this, this is a right angle triangle, this area, and you can just calculate it directly from here. What is the formula for the area of a right triangle?
Half
But
base into height.
Yes, half of the base into height. All right. So what is base here? Capital T and half. And what is the height? Height is GT. So half GT squared. All right. Okay. So here I have X of T, and we are saying that this is area under the curve. All right. So what about the units of this area? What are the units of area in general?
Meter squared.
G?
Meter square.
Unit squared.
Meter squared, right? Meter squared, that's the units of an area. And how about the units of this quantity here? Look at this. ये क्या है? ये क्या है?
Distance.
Meters.
Meters है
Time
सिर्फ.
squared.
ये सिर्फ मीटर है, कोई टाइम स्क्वायर्ड नहीं है, सिर्फ मीटर है इसकी यूनिट. ये डिस्टेंस है. ये इसके अगर आप प्रॉपर्ली वर्कआउट करेंगे तो विल गेट मीटर्स. एरिया हम कह रहे हैं, एरिया. Integral or summation is the area under the curve. Now you go to an interview and then you have this cunning professor who asks you, Well, if this is area under the curve, then why don't I get the units of meter squared, right? अभी इस पे बात करते हैं जी साफी.
Sir, I wanted to ask कि जब area under the curve निकालना है तो we just have to like integrate the value on the y-axis.
We do what?
We just have to integrate the y-axis.
नहीं, इंटीग्रेशन तो x एक्सिस के अलॉन्ग हो रही है, वो तो फंक्शन है
Oh, okay.
जी. नेक्स्ट
इसके यूनिट मीटर
आप जिसका सवाल जवाब दे दिए, अपना हाथ प्लीज लोअर कर लें ताकि मैं नेक्स्ट से पूछ सकूं. जी नेक्स्ट कौन बात शुरू कर रहा था, पूरी करें.
सिग्मा साइन जो है ये समझा दें.
एक मुझे दैट्स इसलिए मैं कह रहा हूँ मुझे रिकॉग्नाइज करने दें. अहमद फराज फर्स्ट.
जी सर, मैं कह रहा था सर, जरा सिग्मा साइन का मतलब बता दें.
किस चीज का?
सर ये जो सिग्मा वाला साइन है ई की तरह.
लास्ट लेक्चर में थे आप?
जी सर, लेकिन मुझे सही समझ नहीं आया.
क्या समझ नहीं आया?
सर बस ये जो नीचे i is equal to 1 और ऊपर n लिखा हुआ है, बस इसकी नहीं समझ.
I have answered this more than twice. Okay, watch the previous video and then come to my office hours. ठीक है अहमद. नेक्स्ट अब्दुल रहमान.
यस सिर्फ मीटर्स ही नहीं होगा आपके एरिया का. एरिया भी जो एरिया के यूनिट्स हमने निकाले हैं वो मीटर्स ही नहीं होंगे
जी, यही तो मैं कह रहा हूँ. ये मैं यही कह रहा हूँ
मीटर्स ही होगा सर.
जो हमने ये निकाली है, ये एरिया निकाला है, एरिया अंडर इसके यूनिट्स मीटर्स हैं. ठीक है. एंड एक्चुअली वी आर कैलकुलेटिंग डिस्टेंस. लेकिन एरिया के यूनिट्स जो ज्योमेट्रिक एरिया है उसके यूनिट्स क्या होते हैं?
वापस हम ज्योमेट्रिक एरिया तो निकाल नहीं रहे, हम लोग दो क्वांटिटीज के अंदर डील कर रहे हैं ना. वी आर नॉट डीलिंग विद द ट्रायंगल. हम क्वांटिटीज के साथ डील कर रहे हैं, वन स्पीड एंड वन टाइम.
हाँ, वेरी गुड.
स्पीड इनटू टाइम आपको मीटर्स ही देगा.
Very good. Yeah, that's the point. That's the point I want to get across. This area, although we are saying that this is area, this is a algebraic area. This is not geometric area. Its units would always be whatever units that we get from the quantities on the x-axis and on the y-axis. All right. So this area in the integration, whatever area, when we talk about the area under the curve, this is an algebraic area. So it is area on this graph, but it is not area in the geometric sense, which has the length times width that gives you the area of, let's say, a rectangle. All right. So this is very important to know that this is algebraic area, okay, not the geometric area whose units are meters squared. Okay. And the second point, okay, first let me, there are a lot of hands raised. जी फराज, आपका क्या सवाल है? जी सैफुल्ला.
सर आपने जो ऊपर ये लिखा है लिमिटिंग सिग्मा वाला, सर डेल्टा x अप्रोचेस 0 क्यों लिखा हुआ है? डेल्टा t नहीं होगा?
थैंक यू. यस जी, ठीक है. थैंक यू. ठीक है. Okay. Another statement that you read very often and it can be very confusing is area under the curve. Well, that's not really true. This statement needs to be re-examined. Let's say you have a situation like this. X, f of x, and this is the function. All right, up to a point capital X from 0. So which area are we talking about? This is our curve.
So area between x-axis and the line and the curve and the line.
X-axis and area with the x-axis.
Yes. So yes, very good. So that's the point, that when we say area under the curve in general, that's quite common to say area under the curve, but what it really means is area between the curve and the x-axis. So it can be on the either side of the axis. It can be above the x-axis. It can be below the x-axis, like in this example. So it really is area between the x-axis and the curve. All right. And other important aspect that this area can be negative. As you see, if you take the integral of this system, you will get a negative area. And that is fine. Of course, geometric area can never be negative. It's only possible because we're dealing with an algebraic area. All right. जी सैफ, अगर आपका सवाल नहीं है तो अपना हाथ नीचे कर लें.
सर एक छोटा सा क्वेश्चन है.
जी जी जरूर.
सर हम टाइम को नेगेटिव तो नहीं होने दे सकते, तो हम मतलब बाद में इसमें मॉड्यूलस लगाएंगे कि
दोबारा बताएं.
सर देयर विल बी केसेस जहाँ पर हम नेगेटिव एरिया एज इट इज एक्सेप्ट कर लेंगे, या फिर जिस तरह टाइम है इसमें या मीटर है तो डिस्टेंस कैन बी नेगेटिव. सर फॉर एग्जांपल हम इसको मॉड्यूलस लगाएंगे हर दफा या फिर कभी-कभार नहीं लगाएंगे?
नहीं अभी देखेंगे. नहीं लगाने की जरूरत. You don't have to do anything. अगर negative area in an integration is negative quantity that you have to deal with. That's the answer.
Okay sir.
So I'm
नहीं होता.
जी.
नेगेटिव साइन सिर्फ ये नहीं दिखाते कि डायरेक्शन ऑपोजिट है, क्योंकि आपका मैग्नीट्यूड तो उतना ही रहेगा. नेगेटिव साइन मतलब डायरेक्शन नहीं दिखाता.
देखिए नेगेटिव साइन यहाँ डिपेंड करेगा कॉन्टेक्स्ट पे कि कौन सी क्वांटिटी आप कर रहे हैं. ठीक है. उसका यहाँ पे अभी सिर्फ हम ये इस सेंस में कह रहे हैं कि इन सम देखें ना, ये देखें -5 +2 +1, ये इसका सम क्या है? -2. That's it. That's integration. Sum can be negative. Integrals can be negative. Okay.
Right.
It gets a bit more confusing because we are dealing with the area, and then we are used to thinking that area cannot be negative, while geometric area cannot be negative. Algebraic area, this is algebraic area. That's why I wanted to make this point. Ji Muiz.
Sir, in this graph, we are when we find the area of the area under the curve, we integrate along the x-axis and find the area. But if in this case we integrate along y-axis, wouldn't the area be the same?
यार y एक्सिस के दरमियान along इंटीग्रेशन नहीं हो रही. यहाँ भी इंटीग्रेशन x एक्सिस के along हो रही है.
नहीं सर, अगर करें तो एरिया सेम नहीं आएगा.
किसका एरिया सेम आएगा?
सर अगर हम इक्वेशन जैसे x को सब्जेक्ट बना लें, y को सब्जेक्ट ना बनाएं, और फिर y के टर्म्स में इक्वेशन लिखें, उसको फिर इंटीग्रेट करके हम एरिया निकालें, द एरिया बिटवीन द y एक्सिस एंड द कर्व, तो वो एरिया सेम आएगा या नहीं आएगा?
भाई देखें मुझे आपके सवाल की समझ नहीं आ रही सही तरह से. y एक्सिस का क्या ताल्लुक है? हम ये एरिया बिटवीन द कर्व एंड x एक्सिस निकालते हैं. x एक्सिस that's the variable we integrate over. Okay. I don't know what do you mean by y here. y और y के दरमियान कोई एरिया नहीं निकाल. There is no integration that you do along y axis. But when I say along y axis, because हो सकता है मैं कर रहा हूँ कल को, when I say कि no integration along y axis, no integration along the dependent axis. y अगर independent variable है, इस तरह से plot किया हुआ है, तो फिर तो अब y इस तरह से, तो y में I can just change my symbols and call it y. Then फिर the important point is that you do integrate along the independent variable, along the independent coordinate. All right. ठीक है. So area can be negative. Let's do another quick example. Here we have f of x. This is x-axis. Right. Here, this point is x, and this point is 2x, right? And now we have to find the integral of this curve from 0 to 2x. All right. So I can write, what I need to do is I can split it, and I have to find these two areas, area of this triangle and area of this triangle. So that would mean my total integral would be A1, the first triangle, and the second triangle, right? Plus A2. And if you want to write it in the symbolic form, this is how you would write. From 0 to 2x, f of x dx. And you can also write it two separate integrals, 0 to x, f of x dx, plus from x here to 2x f of x dx. All right. And now we don't really need to do that analytically, as you know that the height of this triangle. So let's make the function specific. So let's say that it is in this region ax here. All right. So so what you can do is, so the height in this case would be a capital X, and the height in this case is minus a capital X, right? And then if you apply the formula of now in this case this value is negative. When you apply the formula of the right triangle, for the first triangle we would get simply half ax squared. However, for the second triangle we would get minus half ax squared. Okay, and the total integral, or the total area under the curve, which means area between the x-axis and the curve on either side, is 0. So the integral of a function that looks like this is 0. Now this becomes more interesting if you assume a more realistic function. Let's say, and this is an exercise for you to think about and do it. Let's say that you have sine x, and you integrate from 0 to 2 pi and see what is the answer. You can also try integrating 0 to pi cosine of x dx. So if you get used to this idea of looking at the graphs and be able to do integration without doing the explicit integration, I'll do one of these to get the point across. So see this. So sine starts at 0, and at pi by 2, pi, 3 pi by 2, and 2 pi, right? So the period is 2 pi. It goes like this. All right. Now, do we really need to do this integration, or we already know the answer? But it's important, the limits. 0 to 2 pi. This integral is 0. You don't really need to do it. So you know it, but just looking at the graph. Okay. So this is very important to make important conclusion. That's why you see in scientific papers graphs everywhere. And it's important to understand them, how to interpret them, or look at them, and to also perceive and have an idea of the information which is not explicitly there. And that's only possible if we are able to make simple, let's say simple conclusions from, or simple deductions from whatever information is there. In one of the last lessons, we were talking about if you have a function that you don't know its form of, okay, like this, any function, let's say, let's take sine, for example. Can you plot its derivative? So
Yes, sir.
I'm not going to do it, but
Yeah.
you can plot this derivative. And then when you're doing actual exercises or sitting in an exam, and then you're worried whether the derivative of sine x is minus cos, or is the derivative of cosine which is minus sine, and you don't know the if you know this, you can find that out. If you know that the derivative of a function that looks like this, which is in fact sine, it would be 0 here. It would be maximum here. So, and there would be a, between the two graphs, you would see that there is a 90-degree lag, and that's cosine. If this is sine and its derivative is cosine, because you just need to draw tangent at different positions and see what is its gradient, what is its slope. And you can also tell that the derivative of sine is positive cosine x, because you can look at the what happens at 0, and that tells you. All right. You can make very interesting things, and you don't need to remember a lot if you're able to do both. Look at the graph and be able to plot its derivative, and look at a graph and make some guesses about the integral of that function. All right. G Moise.
सॉरी से मेरा हाथ रेज रहेगा.
Okay, a little bit more. So let's see another example.
Sir, the image is blurred.
G.
So camera unfocus हो गया तो हो गया focus. You can continue.
So we have a situation like this, and want to find out the area between A and X. Now this may look a little bit confusing. So on this side, I have a definite number, and although my X is X, and then I'm using another X here. So this, if it confuses you, that's fine. But what I am trying to do by using this confusing symbols is that on this side, I know what my starting range is, what my starting limit is. On this side, I want to be vague. I don't want to commit yet that this limit is at 10 or is 9 or it's 11. It's a variable. I don't want to commit that I am taking the integral between two definite points. I want to keep this point indefinite. Okay, that's why I'm choosing the limit as a variable as well. So I can, when I'm doing the actual calculation, I may choose x to be 10. I may choose this limit to be 20, whatever. That's why I'm using x on this side, right? Now the function is f is equal to c, and c is the height, right? It does not depend on any variable. It's just a constant function, continues in a straight line at a constant distance from x-axis, right? Now the area under the curve, this is just a rectangle, and I know one side of it. The other side would be, so a means distance from 0 to the initial range is a, and x means distance from 0 to x is distance x. So now how do I find this distance, which is the side of my rectangle, right? How do I find that?
So cx minus ca.
X minus a, x minus a, x minus a. So x is this all distance, and 0 to a is this distance. If I subtract this distance from the total distance, then I would be left with this distance here, right? So once I have the side and the height, the area, which we have been defining, is the integral. That would be a times x minus a, sorry, c times x minus a. You see, now by choosing the upper limit without committing to a fixed number, I get a variable area or an indefinite area, because the value of x is not specified just yet. So this area can be anything. Okay, and this area now becomes a function of x on this side, because we haven't specified x. Whenever whatever, so x is variable, and that's why this area now is a function or a variable itself that depends on x. So whatever x I would choose, that would give me the final answer, the numerical number that if you want, if I want. Otherwise, this area is fine. This answer is general enough. If I specify a particular value of x, then this integral, let's say if I choose x to be 5, then this would give me just a number, a definite number. So if that would give me 5 minus a. Well, c and a are constants. Let's say they have some values, but then this is a number. Okay, this is very important. We're going to talk about it a bit more later on. But if we keep the limit, the upper limit, indefinite, and keep the area indefinite, such an integral is called indefinite integral. And if we fix the values on both sides and plug those numbers, this is an indefinite integral, and it gives you a function like this one when you integrate. An indefinite integral gives you a function. A definite integral, when you specify the limits, it gives you a number. Okay.
Sir, don't we need to add the integration constant?
Very good question. We do. Okay, we'll talk about that in a minute as well. Okay. Just wait a bit more. I have not been very rigorous when it comes to the constant of integration, but I'll answer that question towards the end. All right, and another very important conclusion, if you take this a of x, the integral of f of x, and do the reverse process and take this dA of x over x, and if you actually do the integration, this term would be 0, and this, of course, if you apply the rules of differentiation, this would be 1, and we are only left with c. And remember, c is our original function. So with this example, I wanted to show you that the area under the curve or the antiderivative is related to the function itself. So if we take the derivative of the area under the curve or the antiderivative or the sum, we get the function back. And this is called the fundamental theorem of calculus, that the derivative and integral are, the function and the integral are related to each other. And I can give you more examples to verify that, but and there is a way to even more rigorously prove it, but it's in your notes, and just read it, and hopefully you will understand. It's not that that difficult.
सर ये जो आपने लास्ट फॉर्मूला बताया इसको जरा रिपीट करा देंगे?
ये जो लास्ट बताया है,
जी सर।
ये देखें ना, हमने f of x को इंटीग्रेट किया है बिटवीन a to x, ठीक है? तो हमारे पास एक नया फंक्शन आ गया है, a of x इक्वल टू cx माइनस a, ठीक है? तो ये जो लास्ट फार्मूला है ये बता रहा है कि अगर आप इसका डेरिवेटिव लें a of x का, ये है ना a of x, cx माइनस ca, ठीक है? तो इसका डेरिवेटिव क्या होगा? इसका डेरिवेटिव क्या होगा?
C
सिर्फ c होगा, ठीक है? एंड c इज आवर ओरिजिनल फंक्शन. ये देखें ना, ये f is equal to c, so we have recovered function back. We started with the function and we found another function by integration, a of x, and from this function we can go back to the original function. Now this is antiderivative or integral of f of x. Ax is integral of f of x. If you know the integral of a function, you can find the function itself by doing this, by differentiating it.
तो बेसिकली हमने जो इंटीग्रेट हुआ वो था उसी वापस डिफरेंशिएट किया.
बिल्कुल बिल्कुल सही, ठीक है? So you could also write it like this, for example, if you like. ठीक है? And this would be equal to f of x. ठीक है? So in a way, it's saying that the derivative undoes the integration and gives you the function. And you can even show it if you like, for example. If you have a function that looks like this, so f of x and let's say we know its area between A and X, right? And then we want to find out a differential area here. So what would be the area between X and X plus delta X? All right. So the value of the function here, let's say that we take this initial value of the f of X here, this value. So we take this as the height of the rectangle, and delta X is the width. Okay, so the area of this small rectangle here would be,
सर ये रेक्टेंगल की बजाय ट्रेपेजियम नहीं होगा क्योंकि ऊपर कर्व हमारा स्लैंटेड है, थोड़ा सा स्लैंटेड.
हाँ जी, but I don't know if this is a straight line. This is a curve, so I can't. I have to use just one value.
Approximation होती है इंटीग्रेशन के अंदर, मतलब थोड़ा सा तो इधर उधर होता है when we have a curved graph. Approximation ही होगी ना.
जी, that's what I'm saying. So this area is approximately equal to f of X, the height at the beginning of the curve. Of course, we are losing this area, so times delta X. All right, and then you can rewrite it delta A over delta X approximately equals to f of X. And now if I take the limit delta X go to 0, so as I make this as I make delta X smaller and smaller, the closer to this point I bring the other side, this triangle here is becoming, this small triangle here or something that looks like this region here becomes smaller and smaller. That means the error in my estimation is smaller and smaller. And if I take delta X to 0, then I have the exact relationship, and this is on this side I have the definition of the derivative dA over dx, and on this side I would have found the function. Okay, so this is another more formal way of saying that area under the curve is related to the function through derivative.
सर ये दोबारा समझा दें.
जी बताएं, क्या क्या नहीं समझ आया इसमें.
सर वो डेरिवेटिव और इंटीग्रल्स का कंफ्यूजन हो गया है कि लाइक एरिया अंडर द कर्व पहले आप सिखा रहे थे इंटीग्रेशन से आता है, अब डेरिवेटिव से
नहीं. अब तो हम रिवर्स प्रोसेस कर रहे हैं ना, डेरिवेटिव से तो हमने एरिया नहीं निकाला, हमने तो कह रहे हैं कि एरिया का डेरिवेटिव लेंगे तो आपको फंक्शन मिल जाएगा. ठीक है, इस फंक्शन को आप इंटीग्रेट करेंगे इस तरह से तो आपको एरिया मिलेगा, ये जो मैंने लिमिट के अंदर लिखा हुआ है ये चीज. ठीक है, दैट्स a ऑफ x. मैं ये कह रहा हूं इसका डेरिवेटिव लें तो आपको ये वाला फंक्शन वापस मिल जाएगा. अभी हमने एग्जांपल भी की है.
ठीक हो गया.
ठीक है
सर, ट्रायंगल का जो एरर उसका दोबारा एक्सप्लेन कर सकते हैं?
कौन सी, एक मिनट. अच्छा, मैं ये चैट नहीं पढ़ रहा, अगर आपके कोई क्वेश्चन है तो बताएं मुझे. वैसे जी कौन सी ट्रायंगल का एरिया?
सर ग्राफ में आप कह रहे थे जो स्मॉल ट्रायंगल का आप कह रहे थे एरर आता है.
जी ये देखें ना, अभी मैंने ये कोई कर्व है, मुझे इसकी फंक्शनल फॉर्म नहीं पता है ना. ठीक है, लेट मी मेक अनदर ग्राफ हियर. ये इस तरह का कोई कर्व है, मुझे नहीं पता उसकी फॉर्म क्या है. ये x है, ये डेल्टा x है. ठीक है, तो इसकी जो विड्थ है इस रेक्टेंगल की वो डेल्टा x है. ठीक है, अब इसकी हाइट मुझे यहाँ पे पता है. ठीक है, इसकी हाइट है f ऑफ x, और मुझे फिर यहाँ पे इसकी हाइट पता है. मुझे वैसे तो इसकी हाइट हर जगह पे पता है. ठीक है ना, यहाँ पे है ये x प्लस डेल्टा a x. मुझे इसकी हाइट तो हर जगह पे पता है, लेकिन मैं अब हर वैल्यू नहीं यूज कर सकता. फिर मैं ये काम, फिर मुझे बैठ के एक एक निकालनी पड़ेगी. आई जस्ट वांट ए क्विक एस्टिमेट ऑफ दिस एरिया अंडर द कर्व. ठीक है। द क्विक एस्टिमेट इज कि एफ एक्स की जो यहाँ पे वैल्यू है ना शुरू में, मैं ये ले लूं तो दैट वुड बी द हाइट। ठीक है, यहाँ तक ये ले लूं हाइट एफ ऑफ एक्स, और ये डेल्टा एक्स इसकी विड्थ ले लूं। ठीक है, अब इन दोनों को मल्टीप्लाई करूंगा तो ये मुझे ये एरिया दे देगा। ठीक, ए एक्स इज इक्वल टू एफ ऑफ एक्स हाइट ऑफ द रेक्टेंगल टाइम्स इट्स विड्थ डेल्टा एक्स। इसने मुझे एरिया तो दे दिया है, बट दिस एरिया इज नॉट द एरिया अंडर द कर्व, बिकॉज इतना मैंने एरिया छोड़ भी दिया है। ठीक है ना, so this is only an approximate, it gives me a good answer, something close to the area under the curve, but it's underestimated. But if I make delta x smaller and if I bring this line here, abhi itna error hai, I don't know if the colors are really visible, abhi itna error hai, itna area miss kar diya hai, इतना एरिया मिस कर दिया इस अप्रोक्सीमेशन से, इस कैलकुलेशन में। अब अगर मैं x को यहाँ पे ले आऊं मिडिल में और छोटा कर लूं, आधा कर दूं ना, ठीक है, अब कितना एरर है, अब इतना सा एरर रह गया है। ठीक है, ये बात समझ आई
सर? लेकिन एरिया भी तो कम हो गया ना।
But it does not matter, we don't care about that. We care about the error, we are talking about the error. ठीक है, तो अगर मैं इसको डेल्टा एक्स को बहुत छोटा कर दूं तो then there would be no error in this relation, we would get an exact relation. ठीक है, तो मैं डेल्टा एक्स को इधर नीचे लिख देता हूं और इसकी लिमिट लेने का यही मतलब है। Then it becomes exactly.
सर ये डेल्टा एक्स से डिवाइड क्यों किया इसको?
इससे कोई फर्क पड़ता है अगर मैं डेल्टा एक्स को वहां मल्टीप्लाई करूं और यहाँ डिवाइड कर दूं? बिकॉज आई वांट टू राइट दिस एज अ डेरिवेटिव, बिकॉज दिस इज नथिंग बट ए डेरिवेटिव ऑफ द एरिया with respect to x is equal to fx, because I want to drive this relationship. ठीक है
सर, ये रेमंड्स सम जो है उसमें भी यही कॉन्सेप्ट यूज होगा ना?
जी बिल्कुल।
Sir, as we reduce delta x, so are we considering the area of each and every possible like thin line that we can draw until unless we are reducing delta x to a limit of 0? कि जैसे delta x जब 0 पे जा रहा है, so we are adding up the area of each and every small line which comes into that rectangle?
जी बिल्कुल सही है, हाँ ऐसे ही है।
सर एक क्वेश्चन सर, जहाँ बॉक्स के नीचे चीज लिखी हुई है इसका मतलब है कि when we take differentiation of the area with respect to x we get the original function back.
यार मुझे ना आवाज पता नहीं क्यों नहीं सही आती है, थोड़ा ऊंचा बोले।
सर मैं कह रहा हूँ जहाँ बॉक्स के अंदर इक्वेशन लिखी है इसका मतलब, एक सेकंड मेरा माइक सही कनेक्टेड है सर, आपको आवाज आ रही है?
जी जी आवाज तो सही आ रही है मुझे थोड़ी।
अच्छा सर, तुम ये कहते कि ये बॉक्स के अंदर हमें इक्वेशन लिखी है इसका मतलब है that differentiation of the area with respect to x gives the original function back?
Yes. That's what it means. That's what I have been trying to say.
Thanks sir.
जी अजान ब्रेक मैंने अभी देखा है, आप बताएं मुझे होगी अजान?
हो गई है सर।
ठीक है
सर
जी।
सर जो आपने इससे बिल्कुल पहले जो कराया था, जो हम डिफरेंशिएट करके इंटीग्रेट किया था, वो भी ठीक है ना, अगर हम इतना बड़ा लंबा प्रोसेस ना करें?
नहीं देखें, ये तो आपको कॉन्सेप्ट समझाने के लिए कर रहे हैं।
कॉन्सेप्ट सीएसएस कॉन्सेप्ट के लिए ना, मतलब?
जी ठीक है
बस ठीक है।
अच्छा ठीक है। तो
सर वैसे एक बात बताएं
जी
सर, ये जो आप कॉन्सेप्ट के लिए चीजें बता रहे हैं जिस तरह फर्स्ट प्रिंसिपल वगैरह, ये कभी हमें मैकेनिक्स के सवालों में तो नहीं यूज करना पड़ेगा ना?
देखिए ये कैसा सवाल है कि आप हमसे कॉन्सेप्ट नहीं पूछेंगे, ये फिर क्या पूछें आपसे?
नहीं
जो
मेरा
हम
मतलब है
कॉन्सेप्ट सिखा रहे हैं। देखिए
फर्स्ट प्रिंसिपल डेरिवेटिव
देखिए इट्स नॉट it's not school. Okay, here I can't say कि ये नहीं पूछेंगे वो नहीं पूछेंगे, but what I can say is ये पूछेंगे कि जो हम concepts आपको सिखा रहे हैं और जो to our best जो हम समझते हैं कि आपने सीखे होंगे या सीख लिए होंगे, या वो हमने उनको evaluate करना है कि learning कितनी हुई है. ठीक है, तो वो जरूरी नहीं है कि हम जरूरी नहीं है कि आपको कहें कि वही निकाल दें. we may ask you a question which requires a certain concept. ठीक है ना, तो कभी भी बहुत रेयर होता है कि हम कोई चीज जो क्लास में पढ़ाई है वही आपको कहें दोबारा करके दे दें. It's very rare. We would ask you questions and give you problems to solve using these concepts. And if you internalize these concepts really well, if you understand them, and if you understand them in their true sense and spirit, and you do a lot of examples with these concepts, then you would be able to answer those questions more comfortably. And if you don't, that's the point. I mean, I can't say कि ये concept नहीं पूछेंगे, वो definition नहीं पूछेंगे. I mean,
Sir, can you give us some sort of an assignment regarding the sort of questions that you'll include in the quizzes? Because the questions in quick calculus are too simple.
yes. So you have seen recitation 1, you will see recitation 2, then you would see tutorials. So all these places you would be seeing the examples of the problems that you could be asked. Okay, and one more thing. So I'm finishing with calculus today, and I've looked up the quick calculus book. There is one chapter on differentiation and one chapter on integral calculus. There are 2 chapters, and I think you should go through them and be very, very comfortable with any and every concept in there, because that should serve you as a test. If you can read that book and understand and do the examples, I don't know, that there are not many examples in the book, but and the problems, then you're fine. You would be fine in the rest of the course. You would be fine any questions that are asked about this. And if you're not comfortable, then you should worry. Then you should talk to me. You can ask for help with. Now we have announced the TAs, their office hours and tutorials. Go to tutorials, and some of the, for example, I have asked the TAs for this week to discuss limits and things like that. That now I can't go back and redo all over again. And then you would get homeworks. That would be another place where you would learn what kind of questions we would be asking. So the difference in quiz and a homework and an exam is that in quiz we would ask relatively shorter questions, conceptual questions, qualitative questions, and in an homework you will have problems to solve, and in midterm and final term you would have actual problems to solve, real difficult hard problems. Yes, from next week TAs would have their office hours on campus. Okay, so there aren't many rules. You need to remember a lot of integrations from to the reverse process. There are techniques of integration. Unlike derivation, there are rules. There are literally no rules. But looking at few things, you can deduce or make some rules yourself. For example, if you take the derivative of sine of x, I don't know any rule that I have ever used to get this integration. I've never done that. I've always remembered it. Okay. And if the only thing that confuses me sometimes is whether it is minus cosine or plus cosine, the derivative, that I get help from by plotting sine first and looking at its gradient at 0. And if that gradient turns out to be positive, then I know for sure that the answer here is positive. Okay, so there is another useful, for example, trick of getting so when you practice integration a lot and you get used to the idea, you realize that there are actually certain type of functions have certain types of integrals. So then out of memory and familiarity with the functions, you can write their integrals. For example, and here let me show you this. D over dx x n plus 1 over n plus 1. Now if you take the derivative, this derivative, if you evaluate it, turns out you have n plus 1 and then derivative of x n plus 1 dx. and then this becomes n plus 1 over n plus 1, and the rest is just xn. Okay, and then this cancels, and this gives you xn. So the only rule of integration that I know is that if you integrate an integral, it gives you the original function. So now you can reverse this rule. So you can take xn and you say, because we have just shown that xn is derivative of this function, now we can say integral of xn is xn plus 1 n plus 1. So whenever in doubt, if you don't remember, you can always go back and differentiate your answer, and if you get back the original function, then you're sure. So this is another very useful technique. For example, the derivative of e of x is the function itself, only function in mathematics whose derivative is equal to itself, and then so would be the
आपने दूसरे वाले क्वेश्चन की इंटीग्रेशन की है, वो आप स्टेप बाय स्टेप समझा सकते हैं प्लीज? दूसरा वाला जो पार्ट है x
ये
over n plus 1,
इसकी कोई स्टेप
Yes.
बाय स्टेप इंटीग्रेशन नहीं की है।
वो जो आपने लेफ्ट साइड पे की हुई है क्वेश्चन के नीचे, वो उसकी एक्सप्लेनेशन।
वो तो डेरिवेटिव लिया हुआ है, ये डेरिवेटिव लिया हुआ है इस फंक्शन का x n plus 1 over n plus 1, इसका डेरिवेटिव लिया हुआ है। देखिए डेरिवेटिव में आपको पता है कांस्टेंट्स आप बाहर लिख सकते हैं, तो 1 over n plus 1 को बाहर लिख दिया है, डेरिवेटिव लिया है x ऑफ n plus 1, जो रिमेनिंग टर्म है उसका डेरिवेटिव है। तो डेरिवेटिव का रूल है, आपने फर्स्ट प्रिंसिपल से ये शो भी किया हुआ है ये चीज कि यू गेट द पावर बिफोर एंड रिड्यूस द पावर, बिल्कुल ये वाली चीज की है। ये देखें ना, अगर x3 का डेरिवेटिव लें तो वो क्या होता है, 3x स्क्वायर्ड नहीं होता, ठीक है। सो दैट्स व्हाट आई हैव डन, n plus 1 x to the power n plus 1 क्या होगा, n plus 1 बाहर इधर आ जाएगा और x की पावर n हो जाएगी, n plus 1 cancels with x plus 1, n plus 1, and then I get xn, ठीक है। So the exponential is a derivative of the exponential is equal to itself. So the derivative, so the integral of ex would be ex plus a constant of integration. Okay. And there are a few more rules. For example, integral of a, let me go to the next board. For example, the integral of a constant again is equal to ax plus c, where c is the constant of integration, and you can verify this by differentiation. If you differentiate this function, you will get a. Okay. Similarly, you can take the constant out. If you have a constant multiplied by a function and its integral, then you can write it the a out of the integral and just take the derivative of f of x, sorry, integral of f of x. It's another property. If you have the sum of two functions, the integral of the sum of the two functions is equal to the sum of the integrals of the functions. So u dx plus v dx. You can write it like that. There are more rules. I'm not going to just rewrite, copy paste them from the book here. They are given at the chapter in the chapter on differential calculus in quick calculus. So please familiarize yourself with those rules and practice a lot. Integration, you can be better at integration by practice. All right. And before, because we are finishing on calculus, there are a couple of things somebody asked me, so I think it's a good question. People get confused. In a derivative, when we write this whole thing is just one symbol, and it indicates that we are differentiating with respect to x. And whatever is here is what we are differentiating. So this whole thing, dx, this is all a symbol. In a similar way, in an integral, and in some books you may find written the integrals in this way. Okay, and in other books you may find that they choose to write the dx before the integrand. Okay, like this. So this again is a symbol, and dx here is just a symbol. It indicates that the integration is over x. In a similar way, this is just a symbol, and it indicates dx indicates that the integration is over variable x. And this is a symbol of integration. All right. And this is a symbol of differentiation. Now, as you progress in your career here, you would see that there are much shorter ways of writing this notation. Okay. So if you see somebody saying that f is a function and f prime is its derivative, this is just right. This is a short way of writing this whole thing, where prime shows that a derivative has been applied. Okay. So this is compact, but don't worry about it. These are the symbols that we would be dealing mainly. Okay. And this there is no value for dx. You don't need to multiply it. This only tells you that this is the function that we are trying to integrate. All right. Okay, now we deal with the constant of integration. X, f of x, right? And now we have a function that looks like this. Okay, and its functional form is x squared plus 3. Okay, so if you plot such a function, it would look like this. This is 3. Now we want to find the area under this curve, or the integral at these two values, between these two values. At 1 and at 3. All right. So we want to find this area. Okay. So now we apply the rules of integration and we try to integrate this. All right. And if you apply the rules, this is what you would get. X3 over 3 plus 3x plus c. Okay. So this is 3.
एक्सक्यूज मी सर, आपने यहाँ सी क्यों अलग अलग लगाया है? ये हम लिमिट्स के साथ ऐसे ही नहीं सॉल्व कर सकते सी के बगैर?
जी जी, क्योंकि ये कॉन्सेप्ट यही समझाना है इसलिए सी लगाया. ओके, सो I just talked about the indefinite integral. If I do not impose any limits on this integral, this gives me a function, right? Now this gives me a of x. This gives me a of x, area under this whole curve in a way, okay? Or an indefinite area because I haven't chosen the limits. So this gives me a function, okay? So whenever you have, this is the rule about the constant of integration. Whenever you have an indefinite integral, you always have to introduce the constant of integration, otherwise you will get incorrect answer. You always have to introduce the constant of integration. But in our case, we have a definite integral. We have to find the area between these two curves. So how do we impose those limits? How do we plug those numbers in here to find this definite area? Okay, let me say that this area is the one that I've calculated is from minus infinity, from here, all this area under this curve, up to a variable point on this axis called x. But now I want to find this specific area, this area between 1 and 3 on the x-axis. So how do I do that? All right. So we can do that. Just let me rewrite so that you can view it more clearly. So this is the function, and I'm assuming that this gives me the area from minus infinity to an unspecified value x, all this area, all to a 1 point. So if I want to calculate the area from minus infinity to 0.1, all this area left of this point under the curve, that would be just simply, I need to plug this 1 in this equation, and that would give me area from minus infinity to this point under this curve. And that would be 1 cube by 3 plus 3 times 1 plus c. All right. And then if I want to calculate the area from minus infinity to this point 3, it will give me all the area under this curve, starting from minus infinity to 3. Three cube over 3 plus 3 times 3 plus c. So how about this area now? Now I know two areas, one starting from minus infinity going all the way to 1, and another area starting from minus infinity and going all the way to 3. But I'm not interested in the area from minus infinity. I'm interested in the area between 1 and 3. So what do I do with these numbers? How do I get that area from these numbers? Subtract this area up to 3. Sorry, the other way around. Subtract this area up to 1 from this area, and this would be the remaining area, minus a from infinity to 1. And that would give me the area between 1 and 3. Does it make sense? Now let's do the actual subtraction, okay? If we do the actual subtraction, this is 1 over 3, and that's 3 by 4. So this area is 3 by 4 plus c. And this area is 9 plus 6. That's it, right? 18 plus c. And then a minus sign here because I have to subtract. And this would also become minus. So the c cancels. Okay. So this is
जी minus 3 by 4 से आएगा.
It's 10 by 3.
10 by 3 है सर.
So 10 by 3.
कहाँ पे भाई? ये 1 है तो 1 का क्यूब क्या होगा?
So 1 over
1 होता है. 3
1
plus
over
3
3 plus
10
3
over 3 बन जाएगा LCM
9
लेके
plus 1 10 over 3 हो जाएगा।
ओ अच्छा 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 अच्छा, सॉरी, तो ये क्या है ये
10/3.
10 by 3.
10/3. Okay, thank you, that's fine. Okay, but important point is here, you see, when I am subtracting these areas, these C's are canceling, the constant of integration is canceling, and I'm left with a number 18 minus 10/3, area between 1 and 3. So this is important. Whenever you see in a definite integral, when you have the limits specified, so whenever a definite integral is, you're dealing with a definite integral, this integral goes from 1 to 3 f of x dx. Whenever you integrate such an integral, you don't really need to worry about the constant of integration. If the limits are defined, the limits of integration, you don't worry about C. You don't need to write it. You don't need to take care of it because it always gets cancelled identically. Okay. But if you are writing an indefinite integral, you must always write C. So this is the rule about the constant of integration. In an indefinite integral, which is in an indefinite area, you always write the constant of integration. You carry it in your equation. But when you're dealing with a definite integral, you can just not write C. Okay, and one more thing, the way we have calculated these two expressions, let me generalize it. So the integral of a f of x, if I may write it as a capital F, or let's say, capital F of x. F of x is the integral of f of x, the small f of x. And how do you impose the limits? This is how you impose the limits. From 1 to 3, and then you rewrite this integral, evaluate this function at 3 first, minus this function at the lower limit. The integrated function at the upper limit first, minus the integrated function at lower limit, and then this gives you the definite integral, the final number. And this is exactly what we have done. And the concept comes from here, from this graph, from this geometry, that we taken the integrated function, this happens to be Ax in this case, and we evaluated it at 1, and we evaluated at the lower limit and at the upper limit. And then here we took the area, we took the function at the upper limit and subtracted the value of the function at the lower limit, and that gives us the area under the curve, or the definite integral, and it is always a number. Okay, I think that's it. If you have any questions. No questions? All clear?
सर एक सवाल है।
जी जी, दो करें।
सर पहले तो दो कर लेते हैं। सर पहले तो ये बताएं, जो आपने इंटीग्रेटेड फंक्शन में x की कोई भी वैल्यू पुट की, जिसने आपने एग्जांपल में 1 पुट की, आपने यही कहा था कि नेगेटिव इन्फिनिटी से 1 तक का एरिया आएगा, यानी ग्राफ चलता रह रहा है नेगेटिव इन्फिनिटी तक।
जी जी।
तो सर मेरे पास थोड़ा जरा मुझे कंफ्यूजिंग बात ये लग रही है कि मेरे पास एक लाइक न्यूमेरिकल आंसर क्यों आ रहा है? अगर इन्फिनिट ग्राफ मैं चलाता आ रहा हूँ तो मेरे पास एरिया का आंसर क्यों आ रहा है?
ठीक है, तो इसका जवाब इससे नहीं मिला आपको कि ये फाइनाइट क्यों आ रहा है एरिया। ये एग्जांपल हमने इससे पहले भी तो एक की है। ये देखे ना, ये देखे, ये चीज हमने की है कि ये एरिया जो इधर पहले से आपने जितना लिया है, अज्यूम किया है ना, ये
बट वो बोर्ड राइट तरफ हुआ बस, कैमरा राइट तरफ।
ओके 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 ओके, दिस वुड बी 2। देखिए ना, ये एग्जांपल देखे ना कि ये मेरे पास 0 से a इसकी पहली लिमिट है और दूसरी लिमिट है 0 से x। अब मैंने एरिया निकालना है ये वाला, ये इससे आई एम नॉट इंटरेस्टेड इन दिस। ओके, अब मैंने क्या किया है कि यहां से 0 से डिस्टेंस है a तक का, ठीक है, वो लिया है, और फिर 0 से x का डिस्टेंस लिया है, ठीक है। तो अगर मैं x से
Sir, I'm
A को
sorry to
माइनस
interrupt
कर
there.
लो।
सर आई एम सॉरी टू इंटरप्ट दैट, मेरा सवाल का मकसद ये नहीं था। मैं कह रहा था कि अगर आपने इंटीग्रेट किया, आपने सिर्फ 1 डाला, सिर्फ 1 वैल्यू डाली, तो व्हाट डज दैट मीन? आपने कहा ना नेगेटिव इन्फिनिटी से मेरे पास 1 तक का एरिया आ जाएगा
जी।
if I just put, तो वो एरिया आ कैसे सकता है कि वो नेगेटिव इन्फिनिटी से 1 तक चल रहा है? मैं
वो
किसी को भी माइनस नहीं कर रहा।
वो इसलिए आ जाता है, वो मैं समझ रहा हूँ आपका क्या कंफ्यूजन है। वो इसलिए आ जाता है, अगरचे आई जस्ट वांटेड टू मेक अ पॉइंट अबाउट लिमिट्स, आई डिडंट वांट टू कंफ्यूज यू मोर देन। ये देखे ना, ये फाइनाइट नंबर नहीं है, ये कांस्टेंट भी तो है ना, तो वी डोंट नो दिस वैल्यू ऑफ दिस कांस्टेंट, ठीक है ना। तो ये कोई अनस्पेसिफाइड नंबर है, लेकिन वो अनस्पेसिफाइड नंबर इधर भी है ना। दो 2 अनस्पेसिफाइड नंबर्स जो है ना वो यहाँ पे कैंसिल हो रहे हैं। वो जो इधर सारा एरिया है ना इस तरफ, ठीक है, दैट इज somehow taken care of by this C, some uncounted number C, and then you have some uncounted number in the second, and then when I subtracting them from each other, so wo that goes away, and all I get is this area. Is it better?
जी जी सर, वो सी अनस्पेसिफाइड है बस, बहुत शुक्रिया सर।
जी
आपने वो जो क्लोज स्क्रिप्ट का बताना था वो भी प्लीज बता दें फिर।
जी मैं I'll just start in a minute. Okay. All right, do you see the display of my laptop?
Yes sir.
ठीक है। अच्छा, let's make it a bit bigger. ये script readable है?
Yes sir.
Okay, so here I have a function. It's a little program, and if you're wondering why are we being forced to use programming, so I mean anybody who is doing any meaningful research in any area needs to learn programs eventually. So if you learn it quicker, the better. Even the philosophers these days need and use computer programs. So this particular computer program is written in a variation of Python called VPython, and then it is ported in GlowScript to render it in the to render graphical figures and use it in the browser. So let's read this program. So the first line, don't worry about it. It doesn't mean anything that concerns us. The second 2 lines are comments. The program doesn't read them. They are for another. For example, I wrote this program and I had this in mind that you would be reading my program. So these comments are for other readers or users. They don't do anything. So whenever you want to place a comment, you can use the symbol hash and then write a comment. But this is the language specific. If you're working with a different language, this would be different. And the next thing is, of course, the purpose of this program was to be able to plot functions on a computer. So whenever you want to plot a function, you need to define it. So in this case, we have a function. We have a function sine x over x, sine of x. So you have to define a function, and this is how you define a function. We need to use the computer language. So this is the definition of the function. The next 3 lines, just completely ignore them because they are to make the graph look a bit more. It's just the beautification. You don't really need to learn or change them, but if you are able to, that's good. So these are basically labels on the x-axis. I will show you once we will get the graph. And this line is absolutely crucial. You don't really need to understand what it is doing, but what it is doing is it's telling the computer that we want a graph, so we want a figure. So it is kind of creating some space, some object holder in the computer memory, but we don't really need to fully understand that. The rest of the program is what we are interested in. So xmin And you can change some of these values. You can change, for example, the definition of the function. If you don't want to plot sine x over x, you can change it here. You can just say x, and then it will make a linear graph. We will practice that in a minute. And then here you choose over which range you want to make that plot, from minus x to plus x, minus 5 to plus 5. And by choosing dx, again, you can change these numbers and see if the range changes. We are telling how many, how big a division, how many points the computer must evaluate our function between minus 5 and plus 5. Okay. And then I'll probably just increase it a bit because it would take too much time. And then, so then here in the last 3-4 lines, what I'm doing is let's start with x equal to the smallest value in the range, and then keep doing what we are going to do below until we reach x maximum. So that's a loop in technical terms. And in the next line, we are just evaluating the value of the function. We are calculating the value of y-axis given a number, given a value for x-axis. So it gives us just one, it takes one x value, gives us one y value, and then we are immediately plotting that point, x and y on the graph. And then we are changing x to the next point that we want to evaluate. And the whole process would make a very nice plot. Let's see if it does. So run this program. You wait a little while and you low, and there you get the graph. Okay, this is how it looks like. So the beautification part gives us this label here at the bottom, or this label here at the y-axis, or this heading, plotting functions. It does nothing else. Okay, and then this is it. You see the graph is from minus 5 to plus 5. Let's change some value. So let's keep the function as such, and now plot it from minus 10 to plus 10. Okay. Okay. And then after making these changes, run this program again. And now you see that you see a different function, because it's not a different function. Now you see more detail because I'm plotting it over a larger range. All right. And let's change this function altogether. And instead of plotting sine of x over x, let's make the simplest plot that we can. Just a straight line going through the origin. Okay. And that's what you see, that this is a straight line and it goes through origin. Let's change the function to something else. X squared plus 3, right? And then run it again. Oh, what do you think went wrong?
So f of x अभी भी sin x over x
सर dx की वैल्यू कम करें.
ये वो तो लेबल है जो ये f x equal to sin, वो तो that doesn't matter. So okay, well, let me just remove it so that it becomes acceptable. But what happened? Okay, now f of x हो गया है. But what happened here? So why are we seeing this? We didn't expect to get the x squared plus 3 like this.
Dx is too small.
Yes. Is it too small or is it too big? Let's see.
It is too big.
Yes, most likely it is too big. So let's see. If you make it too small, then it takes longer for the program to evaluate.
सर dx की समझ नहीं आई.
जी बता देता हूँ.
सर dx मतलब वो यानी कि डिजिटल अप्रोक्सीमेशन कर रहा है वो जो प्रोग्राम
जी ये आपका कंटिन्यूअस फंक्शन है, आप उसको डिजिटाइज कर रहे हैं. You're plotting it on a computer. ठीक है. एक मिनट. So that's what dx is doing. Okay. So this is a function तो continuous है ना. तो dx ये कर रहा है कि अब हमने इसको +5 तक लेके जाना है. तो this is dx is creating divisions on the of the x's, और फिर उन points पे function को evaluate कर रहा है. ठीक है. और वो दिखाते हुए फिर continuous दिखा देता है, क्योंकि हमने बहुत dx छोटा रखा हुआ है.
अच्छा सर, वो जो x के अंदर फिर हमने जो लूप के अंदर डाले x को हम dx से इंक्रीमेंट कर रहे हैं, तो बस वो फिर ऐड करके उन्हीं वैल्यूज के ऊपर हमें y की वैल्यू दे रहा है।
जी ये इधर से हमने x को -5 से शुरू किया है ना, और फिर हर दफा dx ऐड कर देते हैं, पिछली वैल्यू में ऐड करते जाते हैं, तो इट गोज एंड कीप्स प्लॉटिंग दोज पॉइंट्स। ठीक है, दैट्स व्हाट इट इज डूइंग। Now I think I chose too small a value and my program is stuck.
तो ये प्रोग्राम तो बहुत देर लगाएगा लोड होने में, काफी ज्यादा ही छोटी वैल्यू थी।
Oh, I hope I got it back. Oof. Let's
सर
see.
एक दो डेसिमल कम कर दें।
So it seems some of you are already familiar with computer programming. All right.
Yes.
It still doesn't look very good.
सर आप इसी को zoom out कर दें।
So maybe it's not an issue with dx, maybe it's an issue with जो आपका function definition है return के अंदर, sometimes वो BODMAS rules के ऊपर calculate नहीं properly कर पाता function जो आपका program होता है।
So you mean I should write this?
सर इसकी रेंज बढ़ा के देखें,
नहीं,
x min और x max
वो भी
अच्छा, I don't remember.
x वाला पार्ट ब्रैकेट में कर दें और फिर +3 लिख दें।
यस सर, ये गया था मैं।
क्या 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 अच्छा, ये इसको ये करें पेरेंथेसिस में।
जी, और से जो आपने 3 स्टार बीच में लगाए हुए उसकी जगह वो रेस टू पावर वाला साइन लगा।
अच्छा ठीक है, ओके। The function still doesn't.
सर वो स्टार लगा के देखें, मेरे ख्याल से पाइथन में स्टार ही चलता है।
पाइथन में नॉर्मली स्टार होता है, डबल स्टार फॉर द पावर।
Okay, yeah, that was the problem. Yes. So the power operator is actually double star, not the hat sign. Anyway, so now we have a different function. Okay. And the people who guessed that dx was too small, that's also very good, very smart. So this program is just to help you. You can plot different functions, and you look at a function and you wonder what this function looks like. Well, you can always use this program and just change this definition here and make a plot. Okay. So this is one of the.
Do we have to be signed in to edit the program?
Gigi, I think you have to sign in. I'm sorry about that.
Okay, sir. Yes, sir. When you sent it last week, I couldn't edit it.
Okay, so this was about the plots, and the second is about limits. So it has already run it. Let me just go over the program again. So here we have this this question was asked on Piazza as well, and there is a response. If you are stuck, you can have a look at it. And one of the questions in the recitation was that find the value of a for which the limit of this function a to the power x minus 1 over x is equal to 1. And well, first of all, we'll discuss that. So we have specified a value of a equals to 2. Then we have the function definition. This again here is just the aesthetics. And then next is the object that gives us the figure window. Then comes the range. So we are plotting it between -1 and +1. That's the dx, the interval between points. And then this is again the same loop. And the first thing would just give us the plot of the function. The very first thing would just give us the plot of the function. How does this function look like? And then below here, I have a limit. So I have x naught, which I want to take it to 0. And well, I have x naught is some initial value. I start with this value of x naught, and then I take it to 0. Okay. And 5 somehow is a measure of is a measure of how close I want to get. And again, 3 lines are just not important. And here again, so if you look at this, so what we do is we do a loop, and we we continue doing that loop unless k is smaller than 5, and then we calculate a value x, right? So we take the x naught value, and then we add 0.1's fifth power. All right. So that would be a very small number being added to x naught, and then we evaluate the function itself at that value, and then we just print its values, and then we keep increasing the value of the k. Starting with 5, we keep it we keep making it bigger and bigger. So a bigger and bigger power of a number less than 1 gives us a smaller and smaller number. Okay, and this would be the limit from right, and here we have the limit from the left. Let's see first. Let's run this program and see what do we get. Okay, so we get the graph of the function. This nothing very special about it, but we also get 2 tables here. So the first table is approaching x naught from right. So this is the initial value of x, and we keep decreasing it. We keep making it smaller and smaller, and we make it to the point where it is 1 point. It's like it's 1,000 or more than that of 1. So it's 1 by 1,000, right? And so it's actually 10 to the power minus 3. 1 into 10 to the power minus 3, and we get this number. That's the value of the function as limit becomes very, very small. This number 69339. Now we approach the same function from the other side, from the left side. We start with a small number, and we try to get closer and closer to the 0. And you see the final numbers are quite identical, 0.9633 and 0.9633. So this is the first bit. We just calculate the limit that was asked in the, and you see whichever side you come, you approach to the same value of the function. And you can even see that on graph, for example. Here, if you hover over this graph, when you go close to 0 on x-axis, on the y-axis, you see the 2 numbers near the pointer. The left number indicates the value of x, and the number after the comma indicates the value of the function on the y-axis. And if you go exactly at that point, you see that the limit x going to 0 of this function is approximately 0.694, 0.693. Okay, so we can evaluate limit like this. We can understand the concept of limit like this. Okay, and now the interesting bit, we want to find a value of a for which this function, we want to find a value of a for which when x goes to 0, the function doesn't turn out to be at 0.6, it turns out to be at 1. So we want to push this function up somehow. We want to bring it to 1. Okay, so we have already used the value of a equals to 2. We go back and we do the hit and trial, and we change this value to just directly 3. Okay, and rerun this program. All right, so what is the value of function at x equal to 0 now? You see, it's slightly over 1. At 3, so 3 was not a bad guess. It's a little bit over 1, and you can also see from the other limit, it's slightly over 1, and you can also verify it on the graph that if it was at 1, it would be passing through this cross here and not here. So let's reduce that value. Let's make it 2.718 and then run it. Look, now it's almost exactly at 1. See this? It's very small deviation from 1. So it's almost there. So in this way, we have found the value of a. Okay, this was another question in the first recitation. And this, by the way, is actually this is where the value of E comes from, the base of natural log. And with this, I think that's it. If unless there are questions, I would stop here.
Sir, can you